Rushi Manche, welcome to Validated.
Excited to be here. Thanks for having me, Austin. Been watching these for a while.
Awesome. Well, we're going to talk a bunch today about blockchains, programming languages, Move, but sort of to give a little bit of a scene set. For years, the smart contract language to program in was Solidity. This was the primary language that people programmed in on Ethereum, even though there were sort of a few other options available if you looked hard enough. Um, it seems like many new blockchains that have launched since Ethereum have tried to innovate in part on the language. And that's sometimes by creating an entirely new programming language and new framework. That's sometimes doing like what Solana does and, adopt C and Rust as two major programming languages and then build custom abstraction layers on top of that, like Anchor is. But there's also been a lot of attention recently to the language of Move. And Move was not specifically developed for blockchains or for smart contracts initially, but it was pioneered partially at Facebook and partially associated with the Libra project, which became the Diem project, which became canceled, unfortunately. But you here from Movement Labs, you guys are a big fan of Move. So I want to talk a little bit about what you guys do, what's interesting about Move, and sort of where the reality of Move and maybe the hype of Move either match up or don't match up from the developer standpoint. So let's get into it.
I kick off the origin story. So I've been coding since 14 from Bridgewater, New Jersey, which is like my hometown. So always tinkering around with like Rust-based programming languages. I think I first started like stumbling across Rust for like gaming purposes back in like World of Warcraft days. And then when I kind of got to crypto, I was really intrigued by obviously started off Solidity. Everyone started off coding Ethereum, dApps, and Ethereum mainnet exploration. But the main struggle that I faced is that it's very difficult to code Solidity, and more importantly, difficult to code secure code. It took me hours, and I'm not even the best programmer. I would say like a mid tier. I would say like C tier. It took me hours and days to like debug and to make sure like each line there was no registry, there was no integer overflows. I was spending more time auditing my code than I was spending developing my code, which was at the time like as like a college kid was very difficult and a hindrance to me because I couldn't develop this consumer app that I wanted to like scale from 0 to 1 if I was worrying about smart contract functionality. And ultimately, we're all in crypto not for like the stablecoin and DeFi use cases, but we want to be infrastructure that powers billions of users. So we want the gaming, the consumer, really the retail focused apps. So I think that was the first thing that kind of struck out to me is I was spending more time on smart contract security than I was on an actual interface from an app and acquiring customers from an app.
Yeah.
Which in Web 2 doesn't exist. Zuckerberg was able to build Facebook from his dorm room. He wasn't worrying about if Facebook got hacked. He was more worried about getting his app across Harvard, right? So that was the first kind of major, like, okay, this needs to change.
Sure. There's also just a lower risk too, right?
Yep.
Because if you have a Web 2 social app that has, 10,000 users and it gets hacked, the worst that happens is probably a bunch of people's pictures get changed. But
Yeah.
in blockchain, everything is financial, and also there is no off button. Like once you deploy a contract, it is deployed and good luck.
Yeah, I think because also reputation based, right? Like if Facebook got hacked in Zuckerberg days, they'd be like, okay, like you just lost like 3 pictures. Like when Stars Arena got hacked, that was like a 2-day project that went viral over a day. They got hacked in a week and lost all their consumers, and now it's basically dead.
Yeah.
So financial security is very important because if you get hacked, you basically lose all credibility you have and lose all your customer base overnight, which is not a Web 2 concept.
Yeah. So, fast forward a little bit to like, where did you first learn about Move? What sort of caught your eye as this being a language that was more in keeping with what you were looking for?
Yeah, I think I saw a Twitter thread like I was like 2 years back about the Diem project and then hearing it expanded. Because I was like, Facebook, the biggest consumer app in the world, like the biggest social network in the world, looked at blockchains and it was like the EVM is god awful. And then spent $1 billion in research to bring the Move language. So seeing the article kind of got me looking into the Move programming language. Hearing about Aptos' launch, I would say August of 2022, so pre FTX, was really looking at okay, this is a really interesting framework, interesting language. Spent a lot of time looking at the Move prover, and Wolfgang, who's kind of the head of Move over there at Aptos Labs, is putting a lot of research on the Move prover and formal verification. And to me, that was very interesting, right? Like this was the first time where I felt I can deploy smart contracts and not worry about security, instead worry about the actual use case of the smart contract. So I was actually engineering Aptos early on. I was one of the first 10, 15 builders in space. I was contributing to the first DEX system. My co-founder built the first yield aggregator. So we were two of the earliest grassroots builders in the moving system. Um, and yeah, I think from there we were really looking to expand and move reach to other ecosystems, which I'll get more into.
Yeah, so I want to go back a little bit to that move origin because a bunch of the code that was part of the Libra and Diem ecosystem, and I worked a little bit on that stuff at Bison Trails when I was there because we were, Aaron Henshaw, the co-founder and CTO there, was part of the technical steering committee behind Libra and Diem. But we got to a place with this where, the project was shutting down, but the code was all open source. And so there were sort of two teams that I believe kind of started working together initially and then split off from them. And so you actually have, Aptos, which my understanding is they took a lot of the existing Libra code and they built it into the Aptos network today. And the Sui network that didn't necessarily start on the same code base, but started from a lot of the same, ideological underpinnings. And they both have Move as the VM language they use, but there's some pretty interesting differences between both of those Move implementations. So do we sort of have two versions of Move at this point, or are they still pretty similar from a developer perspective, even if under the hood the VMs work pretty different?
Yeah, I would say the languages are completely different. Like
Mm,
Aptos Move is like DM project essentially, staying in line with the DM principles. Like for example, the Move prover is built into the VM, which was kind of a core principle of the DM project, while Sui Move is more correlated to the consensus mechanisms. So I would
mm,
say Sui Move is tied to like the database consensus and improvements they were made over there. Aptos was focused more on the direct VM itself, and now they're doing consensus improvements. So I would say they're completely different kind of frameworks. I would even argue it's like similar to like JavaScript, where you have like React, Vue, Angular, still frameworks of JavaScript. So if you're a React developer, Vue kind of like it takes like probably a week to learn it.
right.
Same thing with Aptos Move and Sui Move. There's still versions of Rust. Um, so if you know Aptos Move, you probably know Sui Move, but they are different frameworks fundamentally.
The way we originally met and got connected was around this sort of vision for Movement Labs, which is trying to propagate Move to multiple blockchains. And
Yeah,
part of the way that Solana is built is that things actually, you're not running a Rust native program, you're not running a C native program. These things all compile down, and without getting too technical at the end, a lot of it's just LLVM. And so
yeah,
that means you can build a front end for pretty much any programming language out there. And so as Move was starting to get some attention, there was a project at Solana Labs to work at looking at bringing Move support. And then you guys reached out about also getting involved with bringing Move to Solana. So I want to talk a little bit about that work, but sort of as a starter, um, what sort of inspired you and your co-founder to say, look, the impact we want to make in the blockchain space is not necessarily building apps ourselves, but building Move across a broader ecosystem?
I think it comes down to the use case, right? Like building the first DEX and Aptos pre FTX and eventually post FTX. There was two assets on the DEX. It was APT and like Tesla Tala,
Yeah.
which made the DEX not that attractive, especially when the crash happened. So we kind of took a step back and was like, okay, we believe in Move as a thesis, like formal verification, security, parallelization, great stuff, but wanted to bring it to adoption and bring it to Web3 native today. So the ultimate solution was M2, the first Move layer 2 on Ethereum. So
Hmm.
think of all the benefits of Aptos and Sui fully living on Ethereum security as a layer 2. So that same DEX that had two assets and a cold start problem on top of Aptos now can deploy on top of M2. You have native ETH directly. The ecosystem were fully IBC enabled, so you have TIA, Atom. You
Hmm.
actually have USDC off the bat from Noble, as well as you have full EVM assets. So we actually have EVM runtime that lives on top of the Move virtual machine. So any EVM code can run right now, which provides like backwards compatibility and legacy code support, similar to what you guys are doing with Neon and Slowing.
Yeah.
That's kind of the approach that we're rolling out in house for the Move virtual machine.
Nice. And so how has that sort of process been of going to a bunch of EVM devs building on Ethereum and saying, hey, there's actually like you can still build on Ethereum, but you actually now are using Move. Like, because I know there's a lot of Solidity allegiance in the EVM world.
Yeah, I think this is a cold start problem, right? If you have like an app that's like what 10 million TBO, it's all in Solidity smart contracts. the kind of the friction to get, I'm sure you guys have experienced that too. The friction to convert to Rust-based code bases is very difficult. A, because Rust engineers are really, really expensive. And B, it's just like you have to completely scrap all the work you've done and rewrite new code bases.
Yeah.
Which for projects in the bear was very difficult. Now that market's kind of warming up, and especially the parallelized EVM trend is to market, and people are saying like the benefits of parallelization are really cool. So like Monad, say these groups are
Yeah.
really propagating the benefits of like localized fee markets and parallelization for the EVM. We're talking a lot of order books and DeFi projects and gaming projects that have now converted to writing Solidity on top of our move base because you have all benefits of parallelization. You live on Ethereum for security. So for them, it like the pitch 6 months ago probably didn't make sense, but now it does.
So walk me through a little bit of how that works, because one of the challenges with parallelizing EVM has always been that ETH transactions are not deterministic in terms of
Yep.
all the state. Like you can't actually simulate an Ethereum transaction and know for certainty this is all the state it's going to touch. So when you're dealing with a, an interpolation layer to then get that down to move, like, is there an overhead there for it guessing wrong sometimes, or how does that system actually work?
So we still retain the same Diem virtual machine. So you have the block STM pattern built into the VM. So it's still optimistic parallelization from the Aptos project.
Okay.
What we built on top of the move VM is essentially an interpreter that's eventually be converted to a transpiler. I'm not going to get into the technical differences, but basically you have opcode compatibility for Solidity to move. So if you write
Yeah.
Solidity smart contracts, it's like 142 opcodes, I believe. You map that to the 54 opcodes and invoke functions on move VM. So the end state is essentially the same parallel processing that you see in Aptos. It's just that you have the Solidity opcodes mapped on top.
Yeah, this is basically what Android did with Oracle and got
Yep,
into in that case, many years lawsuit. And in this case, probably no lawsuit since it's all open
because open
source.
source. Hopefully, no lawsuit.
Yes.
Ethereum Foundation.
um, but yeah, so that's like an interesting structure that you guys are kind of going with there. Do you see that as kind of the main way you expect a move to get adopted is through, transposing and compiling from Solidity as a runtime and then using Move on the runtime? Or are you guys more focused on actually getting more developers natively building in Move?
I think for us, the EVM compatibility is just a short term fix. The
Mm.
long term and 3 to 4 year bet is move adoption. We believe that the language built by Facebook, now guided by both Aptos and Sui, over the next 3 to 4 years is going to thrive. A, for financial reasons, and B, just in terms of technological reasons. But to face it, most of the developers, and if not like the 90% developers, are still Solidity developers today. And the issue with next gen tech stacks is lack of legacy code adoption. So just because you have a PS5, if you don't have any games that work from the PS4, it makes it difficult for users to actually use the PS5. So that's why we are looking at we believe that developers are going to switch next gen languages and frameworks, but you still need to have EVM compatibility for existing legacy code. Otherwise, you're going to have a hard time bootstrapping network. And then once you have network, once you have TVL liquidity, and you have the snowball effect where you can attract more users, that's when you can usher in new developers to move. But we're still, quite frankly, early from that. Still early stages. You guys saw the early stages of Solana. It's very difficult to get people to write Solana VM code, and we're just getting started.
Yeah, I mean, the thing Solana had to do in the early days was be 1,000 times faster than the EVM because no one would sort of give the language and the not the language, but give the VM style and the VM differences any look unless you could say, look, you're going to get 1,000 to 10,000x performance increase by doing this. It fundamentally changes what you can build. So if you're sort of in that situation where you've got a developer that maybe they're building in Solidity now, maybe they're building in Rust, maybe they're, something like that even. What is that sort of value proposition to say, hey, Move is worth your time learning and switching over to?
I would say, in addition to the parallelization and speed pitch, I think it's similar to Solana thesis. I think the security is a paramount thing. Security comes out of the box with Move. You have Move approval and form verification built into the VM. So when I was coding Solidity and even coding Rust back in the day, if I was able to use Move, I'd probably reduce my developer time by 1/3 to 1/4
Yeah, so I want to
time.
talk a little bit about
Yep.
where actually you're seeing Move get more security because yeah, the EVM is formal verification.
Yep.
Provers exist on other networks too. So I just want to get a little more granular when you're talking about Because this is the thing you hear a lot
Yep.
is, "Oh, Move has great security." What does that actually mean when you're coding?
Yep. So within the VM itself, you have a bytecode interpreter and bytecode verifier. So when you execute a smart contract, the move prover essentially looks at each line and says, "Hey, is there a history bug? Is there a digital overflow?
Mm,
Did you mess up somewhere?" So you actually have the auditing like effect that auditors do like after correction in real time. So every time you execute a smart contract, it checks for these resource type and memory safety.
yeah,
When you actually look at a history of attacks, it's not off the first deployment. So if you look at the Kyber
yeah.
attack, it was actually like the 50th push or the 54th push made by a random developer that they forgot to check one line, and that costed Kyber the entirety of their portfolio, right? I see
Yeah.
them in the curve attack. It's usually a small error that I think for Kyber it was 0.0001% probability that anyone could pick it up, that no human or auditor can pick up usually by hand. I think like 92% of EVM protocols are at risk of being hacked. Move fixes that by running each code and running formal verification at runtime. So essentially, you have an
Mm.
auditor working for you in real time instead of waiting to do it after, which is usually the downfall for these EVM projects.
So if it for example, if you're a developer and you're deploying something and there's a there's an error in it, what happens? Does the program deploy fail? Does the program just refuse to execute on mainnet now? Like, what does that failure state look like?
It'll toss a compiler flag and be like, "You messed up like this line."
Oh, it's in the
Um,
compiler stage, not
yeah,
the
yep,
okay.
yep,
I thought you meant like in the VM stage when it was
yep.
deployed. Yeah.
Yep. So this is like multiple errors. They have compiler flags that you can add on. I think even like Arbitrum does this with EVM++. There's
Yeah.
also VM errors that can flag. So you can have errors in multiple stages. And we're also working on throwing more compiler flags so you can get picked up earlier. Because I think like right now it's like 90% more secure than EVM, and now like adding in more compiler detection actually brings that up to higher percentages.
Yeah, it's interesting to think about this stuff, especially in the context of AI, both auditing and attacking of code bases. Now,
Yep.
I do think there's a little bit of a reckoning for the open source community on how do we actually start responding to this sort of stuff when as you're saying, like it might be very hard for a human to catch one of these bugs, but suddenly if you have AI systems going at them, maybe we're 50% more likely to find one of those bugs within a 1-year timeline or something.
Yep. But I think like with AI, the issue is that you need to have enough trained data. So I think we're very early for that. Like I've played around with a few AI formal verification systems, and usually they completely miss because you don't
Yeah.
have like you don't have 8,000 different curves, 8,000 different Kybers. You have like five good ones that are live on mainnet. So the training data isn't enough yet. In a world where you have a billion
Mm.
users on chain and you have like a billion financial applications, that makes sense. But I don't think AI is there already. I think you need formal verification provers.
Yeah. Yeah, formal verification's been kind of an interesting component. It is hard to keep an evolving system formally verified.
Yep.
And so, like with the divergence you're talking about between the Aptos flavor of Move and the Sui flavor of Move, like, do you have a sense of how they're actually doing that sort of concurrent verification work as they sort of start to diverge from like a core product?
I don't want to speak for both teams with thesis, but from my understanding in conversation with the teams, Aptus is focused on the VM style, which is the move prover,
Hmm.
which Wolfgang kind of spearheads over there. I believe Sweet's targeting from a consensus mechanism, trying to embed security. I know they're a pretty stacked ZK team, so looking to like ZK logging and a few ZK cryptography initiatives. But I believe they're targeting through consensus and not from the VM level. But I could be wrong from Sweet style. I'm more familiar with Aptos' thesis.
Yeah. So, when you're looking at sort of like we talked about the move L2 on Ethereum or maybe on something like deploy on Celestia in the future, are you guys primarily working with the Aptos flavor then?
Yep, we're probably looking at Aptos flavor just because the VM itself is designed to be modular, while SweetMove's VM is designed for more for its consensus mechanism. We support both styles of move because we have RPC translation layer on top of the move VM.
Hmm.
Because the bytecode for both Aptos and SweetMove are still the same. Sometimes like JavaScript bytecode is the same for React and Vue. Just like how you translate the RPC code. With that, the trade-off is like the benefit of SweetMove is the way it interacts with consensus. We
Yeah.
don't retain that for obvious reasons because we don't have Sweet's consensus. It's more about providing compatibility to SweetMove projects. But Sweet is definitely the best place to write SweetMove because of its correlation to consensus mechanism.
Yeah, because Sui's got two different consensus mechanisms that a
Yep,
transaction can go through. So there's a lot more to account for there.
yep, yep. It's very difficult.
Yes. So when you guys were looking at something like move support on Solana, what initially attracted your attention there to say like, ah, this is actually something worth doing, as opposed to looking at bringing move support to Avalanche or some other network?
I think for us, first of all, I'm a Solana bull. Like I use Solana every day. I send Solana to my mom via USDC a lot. So um, I'm a diehard Solana maxi, if that works. And the second thing is our thesis is move everywhere with movement. That's kind of like even in our backgrounds. We envision a world where the move framework and move thesis is embedded into every blockchain through one shape or form. Whether that's the move prover existing in current systems like Avalanche, Solana, whatever, or people were starting move smart contracts. So obviously, with the LLVM implementation, you wouldn't get the move prover. But what was interesting is we could essentially bring the move programming language to Ethereum because it is LLVM. You can have multiple programming language, and I saw that you guys were already doing it. I checked out
Yeah.
the LLVM branch. I talked to a few of the engineers, and it seemed like this is a product you guys have been working on for quite some time. Obviously, it's very difficult, and you guys are propagating the SVM, and your thesis is making SVM as strong as possible and Anchor as strong as possible. But given like our experience with move compilers and kind of the reading like the leading voice like Moj or move or like move outside of existing environments, I think that's what attracted us, and something that we're working on right now with the Solana team is bringing the move language to Solana would unlock a lot of different benefits for them.
Mm.
Developers, A, by having like existing move developers go cross chain, and B, you'll actually have like some of the move security inherited because a lot of the move security comes from the move contract itself. You have
Right.
like better account models, you have resource security, you can have custom defined modules. So if you're building a gaming app, you can define like a module design for a specific, let's say, gun or player, and have customizations on the module.
Mhm.
And then from there, you can kind of experiment with security advantages.
Yeah. It's kind of interesting when you think about like the idea that a programming language can sort of be the main characteristic of a blockchain. Which is sort of interesting because if this was sort of the thing that I think a lot of people were talking about Sui and Aptos in the beginning is like, oh, their main advantage is that they have move. And it's kind of interesting to sort of be like, M for you, and you're not quite saying this, but move is not actually a moat, and that a lot of
Yep.
networks can benefit from the same characteristics that Sui and Aptos have just sort of had a first mover on.
Yep.
No pun intended.
Yeah. Ethereum's first mover advantage was solidity in the EVM compared to Bitcoin, right? But after like these other VMs came up, the moat wasn't that solidity at all. In fact, it was become a weakness. The moat was the fact that you had the most TVL and most security on chain. So same thing that happened since Sui. Move was the first thing that got people excited, but now like Sui's focused on ZK and cryptography. Aptos is focused on formal verification, more consensus mechanism research. So Move is actually not a moat anymore. In fact, we've proven that it can be brought to other ecosystems. And now it's the framework that's like open source and anyone can adopt. And Polkadot, I think it's a Move Polkadot palette now.
Oh, cool.
So we're seeing it actually adopted as Move module and Cosmos as well. So it's interesting to see Move pop up in other ecosystems as well.
Yeah. So in terms of, most languages have some form of trade-off in terms of performance optimizations versus usually how easy it is to write in it, right? Like
Yeah.
the classic version here is well, Rust is not necessarily the easiest language to write in. It's a lot easier than C, but it
Yep.
is faster if you write stuff natively in C. Where does Move kind of fall on the spectrum?
So we've been doing a lot of outreach in university and developer groups, and it seems like Move has been the easiest language to pick up out of traditional Rust and traditional Solidity. Just because it's very object oriented, there's less
Yeah,
opcodes you need to worry about. I think it's like 54 opcodes in Move, and this amount of time it takes to write code. There's some diagram somewhere that says to write like account checks for
yeah,
Move, it's like this much. For any other like code base, it's like a page, and slowly it's like 3 pages. So if you're like a university dev, you're like 24, you don't really know how to code. Move
yeah,
is probably the easiest language to pick up because you don't have to write 30 pages of account checks. It's
yeah.
probably done for you. And you can focus more on the product distribution of the product.
Right. And then in terms of like the actual code performance, right? I think that's kind of where Anchor on Solana sort of has a little bit of this problem where it's much
Yep.
easier to write in. It's not a language, it's a framework, but the framework of Anchor is quite easy to write in. You do take a performance hit writing in Anchor versus Rust, and then you take a performance hit writing in Rust versus C, and then you take a performance hit writing in C versus Solana native for your program.
Yep.
So this is also like the Swift versus C on the iPhone kind of perpetual debate. So, like in that stack, is Move performance about par with Rust? Is that sort of what you'd say?
So my general thesis, taking a step back, is if you look at Web 2, you had JavaScript and you had like obviously HTML, CSS below that. You had
Yeah,
JavaScript above that, and you had React, Vue, and Angular
yeah,
on top of that. So you see the same performance kind of trade-offs. Obviously, if you just like hard code it, everything HTML, CSS, and C, like the compiling times be quicker. But how are you going to do that? And it's like very difficult for normal developers to do that. That's why React, Vue, and Angular got adopted as the three main frameworks to build websites. Technically, it's slower, but the developers, users don't see any trade-off, and the biggest websites today are written in that.
right,
Same thing with blockchains. I believe the three frameworks that have risen is Aptos, Move, Sui, Move, and SVM. They can all coexist, all have their own benefits, trade-offs, whatever. Users developers choose what they want. There is performance trade-offs in terms of speed. I don't think it's noticeable to the point like Anchor. I mean, it's very minute to the point where it's a trade-off. I would
right.
say if you're a developer, Anchor, Sui Move, and Aptos Move is still the best way to write Rust-based contracts, even though like you're sacrificing a little bit. The trade-offs in terms of go-to-market, user experience, security is
Sure.
far worth like the 0.01 millisecond difference or whatever.
Yeah. I think that's fair on the user level, right? Because I think that is kind
Yep.
of one difference here is like most people who are building stuff in Move, they're not necessarily building groundbreaking, frameworks that are going to become the basis of the next generation of DeFi. They're building DeFi primitives or they're building DeFi applications, but it's one level sort of higher up in the stack, for lack of a better term.
Yep.
So, I think when you sort of look across the blockchain space from like an education perspective, there's a ton of work that's been done on sort of developer education over the years. I'm sure you guys are doing your own when it comes to Move. Do you have any sort of sense of like what works well and what doesn't? Because I think there's almost this like paradox people get into where Near had one of the best sort of developer education systems out there, but they almost made it too easy. And then,
Yep.
the types of developers that they attracted, maybe, a lot of them weren't as strong as, some of the developers that had to chew glass on Solidity or Solana to like get to that place. So how do you sort of think about that balance when it comes to onboarding new developers?
I think this is what Solana did maybe the best out of anyone is kind of preventing mercenary developers and prioritizing in-house organic developers. So that starts off with like not throwing a grant at every developer that's interested
Yeah.
and be like build this, and then when they run out of money, they then go to the next chain. It starts with like how you're funding developers and how you're giving developers economic incentives, because ultimately the goal of a developer is to make a career on a platform. If a developer can't
Yeah.
have a career on a platform, they're going to keep jumping ship to whoever the hottest person on the block is. Solana did that even to the bear markets, to the hackathons, and keeping the developer community as tight knit as possible and prioritizing the projects, giving them the funding, giving them ecosystem traction. So you're able to retain developers that way because there's a loyalty to the chain and actually a business model built in where these developers actually have money. They're able to feed their families by building on top of Solana or the next gen chain. Other developers and other ecosystems have kind of seen the issues where they'll throw grant money, forget about the project. 6 months later, the project's on the next chain.
Yeah.
So something that we're focused on, and I think the movie system generally is focused on, is prioritizing developers that have long-term growth, contributing kind of open source contributions that are more than just like a simple DEX fork on top of native chain infrastructure. I think what Sweet's focused on is a lot of ZK cryptography work. Aptos is focused on a lot of like consumer partnerships. So both these ecosystems are kind of prioritizing their own use cases. For us, we have the benefit of inheriting that instead of focus on distribution. So I would say just generally having a tight knit consumer base, hosting hackathons in person, and kind of prioritizing the degen developer community is the best way that you retain developers. Making sure they have partnerships, have friends, have a current tight knit community system. That's how you retain them.
Yeah. So what does the Move sort of developer community look like now? Are there sort of pockets in the world or certain types of applications that folks are primarily building on Move now?
Yeah, I think according to Extra Capital, Aptos is the fastest growing non EVM. Obviously, given the fact that it just launched, that's how the percentage is
Sure.
calculated. But like if you just
the
launched
first
last year,
the
obviously
first year percentages are always a little funny. Yeah.
Yeah, but we've seen a great uptick, especially like launching post FTX. You kind of expected nothing to be there. I think the count is like their number move is number 8 in developer count or number 9, something like that.
Yeah.
Which for a first year ecosystem is pretty vibrant. We're seeing a lot of growth in Southeast Asia, Korea, Taiwan. Korea especially is big.
Mm.
Aptos has a big kind of flag there with SK Planet, Hash, and a few other groups. So we're seeing a lot of developer communities come from Asia to start with, and now the kind of focus, or at least our focus, is North America, Europe adoption, where core Ethereum and kind of Cosmos folks are.
Yep.
So yeah, this general move adoption I say is Asia based, but our thesis is trying to bring it towards retail.
Nice. It's interesting. So for Movement Labs itself, like talk to me a little bit about how the org is structured. Like, are you guys primarily grant funded from different blockchains? Like, what's the sort of long-term vision of that corporate entity?
We've raised funding from private investors through private rounds. So that's how we grow our team. I think the team's like 17 deep right now. Tarab actually had a video, was the head of ecosystem Marinade. So we have Solana ties and love Solana and trying to like embody our hacker developer community and learning from what Solana did, given the fact it's probably the most exciting ecosystem right now and you guys have crushed it in every shape or form. So yeah, I think we're privately funded and now going to raise more future rounds and push product towards test and mainnet.
Yeah. So walk me through a little bit of like what that sort of investable vision is. I think it's very easy to look at what you guys are doing and saying like, yeah, this is a great public good. You're bringing a new programming language to a ton of blockchains, but investors obviously don't usually invest in public goods.
Yeah. Well, the main value prop is layer 2 on Ethereum. It works. It works and functions like any other layer 2. So things like arbitrum optimism. I think what we see in 2023 is all these like different DA layers rise up. So like Celestia, Eigen, Avail. I think 2024 has proven to be the year of the next gen VMs, where you have Solana VM obviously kicking up. A lot of people using next gen VMs there. Move has been crushing in the last few weeks.
Hmm.
So we're seeing a lot of people, especially in the Ethereum and Cosmos communities, embrace alt VMs and next gen VMs
Yeah.
because they learned that they could keep the existing security and community of Ethereum, but still use an next-gen virtual machine. So that kind of combination has enabled us to A, attract interest from investors and raise private funding, and then
Yeah.
B, kind of label ourselves as leaders as like the modern move category.
So in that world where we're now basically talking about, the ability to program on multiple languages and support new VMs, what is Ethereum doing in that stack at that point? When
Yeah.
you're now programming in a different language, it's executing in a different VM, it's settling to a different DA layer like Eigen or Celestia, which is not actually technically Ethereum, especially with Celestia's case. So, like, walk me through like the Ethereum quote unquote alignment thesis when we're talking about new VMs and new DA layers.
So the value prop is that Ethereum is the best settlement layer today, given the fact that it's been battle tested, has TVL, ETH is used as stable money in as many people argue. So Ethereum would be settlement in this case, where any transaction or any infrastructure application leverages Ethereum security, decentralization, and network effects to bootstrap liquidity. So if we go back to the DEX example or like a yield dagger example that my co-founder built on new L1, there was pretty much no liquidity at the time. I think it was like
Hmm.
30 million when we were at peak when we were launching. That same DEX and yield dagger can now deploy on top of M2, which is our L2 product, have native ETH directly, which has some assets and has actually liquidity to the products. If you're a liquid fund or family office, if you want to use the layer 2, you can just simply deploy the ETH. You don't need to buy APT or Sui, which is obviously a volatile asset and prevents
Right.
retail capital from coming in. So our value prop is if you're a whale, if you're ETH whale, or even if you're a retail user, you can use Move apps by using like staking ETH, leveraging ETH, not having swapped to native asset, and have all the benefits of Move security and full verification into the VM.
Yeah, I guess I'm just curious because um, the classic version of how you solve this was just you build a bridge from Ethereum to Aptos, and people can use their Ethereum then on Aptos or Sui or Solana directly. Um, but that never quite caught on in the same way,
Yep.
and I wonder how much of that's like bridge reputation versus because like the L2 bridge is still a bridge, right? Bridging to
Yep.
an L2 is still a bridge, and like the UX is if anyone who tried to get ETH Denver tickets for free this year, the UX still needs some work.
Yeah. I would say that there's two main things here. A, security. We've heard and seen all the horrible hacks that have happened that have
Yeah.
led to that. And then B, the kind of user experience. Like if you look on Apple right now, there's three different USDCs. There's like Wormhole USDC, Axel USDC, Layer 0 USDC, and
Yeah,
then
it's
same for
great.
like USDT. And then like it's just like the user experience when you have five different USDCs probably like turns off most people.
Sure.
Same with ETH. If you have like five different wrapped ETHs, with us, with like a layer two, you have native bridging essentially because it's trust minimized bridge, living on top of Ethereum and the valor set there. So you don't have to worry about that. You can just bridge from Sequoia.
I will say trust minimized and fraud proofs are not the same thing, but
Yep.
yes, there is it is a closer system at least. I'll give you that.
Yep. Exactly.
So, what do you see as like the next evolution of Move? We have these sort of two flavors of Move, like kicking off. Like, do you think they're gonna keep diverging, and what can people who are excited about Move kind of look forward to over the course of 2024?
I think they will keep diverging just because the nature of the two ecosystems. That's an unfortunate truth and something we're working on
Yeah.
from a cultural point of view and technological point of view. Uniting the tribes has been difficult to prove, to say the least, but we're doing our best. And then, kind of in terms of the next steps to Move, something that we're doing a lot of research into the ZK Move. We saw the EVM to ZK EVM trend. I would argue that ZK EVM wasn't that much performant than the EVM that we saw. So we are actively looking at the ZK Move thing. The issue is that proving costs today for any zero knowledge provers are way too high. I think our benchmarks for like 4 to 5 cents for current risk implementation, which makes the transaction fee pretty difficult. So we're currently in the process of hiring ZK circuit writers and exploring our own ZK Move VM and trying to get a proving cost as low as possible. Ideally, less than a fraction of a cent, which then it makes sense to use it, and then you have all the benefits of security, validity proofs, and even privacy ultimately. But that's still very theoretical, still very down the line. I think the main push is just getting adoption for Move. Move, we believe, is a tangible improvement for current implementations, and now it's about getting it into retail markets, specifically getting new developers to use it. Given the fact that Facebook is a Web 2 kind of ecosystem, since we both have Web 2 ties and backgrounds, the thesis isn't to get Solana developers to migrate to Move or Polkadot developers to migrate to Move. The thesis is to get JavaScript developers and retail developers from Facebook or consumer app ecosystems to use Move. So I wouldn't say it's predatory to current Web2 ecosystems. We're not all trying to exchange the 5 developers we're grant chasing. We're all trying to tap into the millions of developers that are trying to look into Move, look into Web3, but never thought to do so. And our thesis is if you're developing Web2, you probably feel comfortable writing the language that Facebook built. And now it's about distributing that.
Nice. Well, Rishi, if people want to learn more about Move, to get started programming on it, or keep up to date with what you guys are doing at Movement Labs, where do you recommend they go?
I would first read the Move book. That was written by the early Diem projects. Kind of goes into every semantic. There's a bunch of YouTube videos. And I think Aptos and Sui both have done a good job of in-depth documentation, hackathons. Sui hackathons are some of the most fun. Second to maybe Solana, maybe. I've loved the Solana hackathons and hacker groups. And then for Movement Labs, at Movement Labs XYZ on Twitter, you can follow me at Rushi Manche on Twitter, endless ship poster and technical memer. So you can follow my content, as well as we have YouTube videos, a bunch of podcasts like this that kind of explain the thesis, how to get started, and join the Discord.
Love it. Well, thanks for joining us today on Validated.
Thanks for the time, Austin. Really appreciate it. It was a blast.